Hey everyone, welcome. Today, we're going to level up our algebra skills and tackle a brand new kind of equation.
So you're probably already a pro at solving equations like the one on the left, right? But what happens when that pesky little x shows up on both sides of the equal sign? Well, that's our new challenge. And don't worry, we're going to break it down together.
All right, let's jump right in. We're going to use a super cool visual method with shapes to make these problems way easier to understand.
Now, this is maybe the most important rule in, well, all of algebra. Think of it like a balancing scale. Whatever you do to one side, you have to do the exact same thing to the other. It's the one rule we absolutely cannot break, ever.
Okay, so here are the tools we're going to be using. It's kind of like a secret code. Open shapes, they're positive. Filled in shapes, they're negative. Easy, right? We'll use rectangles or circles for our variables, our x's, and squares for the plain old numbers.
And this leads us to our secret weapon. It's called a zero pair. Basically, a positive and a negative of the same thing, like an open square and a filled-in one, totally cancel each other out. Poof! They make zero. This little trick is going to be a lifesaver for simplifying these equations.
All right, enough talk. Let's put these tools to the test with our very first problem. 4x plus 1 equals x plus 7.
So here's the game plan. Just 4 simple steps. First, we'll draw it out, modeling the equation with our shapes. Step 2, we got to get all the x variables to hang out on one side. Then step 3, we isolate those variables by getting rid of the numbers. And finally, we just group them up to find the answer. And voila! Look at that! After we follow those steps, you can clearly see that each x rectangle matches up with 2 of the little unit squares. So our solution is x equals 2.
Okay, you're doing great. Let's kick it up a notch and see what happens when we throw some negatives into the mix. But don't you worry, the rules stay exactly the same. All right, take a look at this one. 2x plus 3 equals negative 3x plus 8. Now I know, it looks a little scarier with that negative 3x in there, but I promise, the rules haven't changed one bit.
So you might be wondering, how do we get rid of those negative variables? We can't just erase them, right? This is where our zero pair trick comes back in a big way. We're going to add 3 positive x's to both sides. On the right, that creates 3 zero pairs that just vanish. And just like that, we're left with only positive variables. And of course, the whole time, we're keeping that scale perfectly balanced.
So after those zero pairs work their magic, look what we have. 5x plus 3 equals 8. From here, it's easy peasy. We just take away 3 units from each side, and suddenly we have a super simple equation. 5x equals 5. And you know what that means? If we have 5 x rectangles and 5 unit squares, it's pretty obvious that each x has to equal 1. See? Not so bad.
Okay, let's flip the script. What if, instead of the equation, I give you the picture first? Let's try working backwards.
When you see a model like this one, your first job is to become a translator. You've got to take this language of shapes and translate it back into a regular old algebra equation. So take a look. What do you think this picture is trying to tell us?
Okay, let's decode it together. On the left, we've got 5 filled-in circles, so that's negative 5x, and 4 filled-in squares, that's negative 4. On the other side, 7 open circles, that's a positive 7x, and 5 open squares. You got it, that's plus 5. Put it all together, and our equation is negative 5x minus 4 equals 7x plus 5.
Now we just solve it like we normally would. I'd probably start by adding 5x to both sides to get all the variables together. That gives us 12x on the right. Then subtract 5 from both sides to get the numbers together. That leaves us with 12x equals negative 9. A quick division, and we find that x equals negative 0.75.
You know, before we get to your assignment, let's take a quick break. This idea of balance isn't just for math equations, it's pretty important everywhere else too. I mean, think about it. You've got to balance your time at school, making sure you get your work done. At home, you balance your time with your family. Even in your community, it's all about finding that right balance. It really is a key to success.
All right, enough from me. It is your turn to solve. Let's see what you can do. You've totally got this. Okay, it's time for your Lesson 5 assignment. Now listen up, because I want to go over what you need to do. There are a couple of really important things you don't want to miss.
Okay, so this is super important, so please pay close attention. First things first, your questions are on a downloaded worksheet. They are not in Buzz, so you have to download that sheet. Second,
please, please, please read all the instructions on that worksheet carefully. And here's the big heads up. This time, you're going to be writing the word problem from the equation. So you're the storyteller this time. And hey, if you feel like you need a little more practice, don't forget to check out the extra problems in the digital math journal.
So, to get your brain warmed up, think about a problem like this from your worksheet. Which of these situations would you use the equation 12x plus 10 equals 15x plus 8 to solve? You'll have to read each scenario really carefully and figure out which story is a perfect match for that equation.
You've got all the tools and the methods now, so go for it. Good luck with the assignment and have fun solving.